Okay, in this lesson, 10.3, we're talking about properties of logarithms, and of all this chapter, this is probably the lesson that students struggle the most with, because you need to know these properties, and you don't know the properties yet. So properties of logarithms. Logarithm of a product is the sum of logarithms of its factors. So if you have a product, log of a product, you can what's called expand one log to be 2 logs. So notice you have 1 log and now you have 2 logs. For this other side is called condense. So expand means to get bigger is expand. Condense means it's big and you're making it smaller. So to condense, you have multiple logs, 2 logs, and you merge them, you condense them to be 1 log. So you have 2 logs and you're going down to 1 log. So there's a relationship between product and sum, so multiplying and adding. The logarithm of a quotient, quotient's a fraction, is the difference of logarithms of the numerator and the denominator. So if you have a quotient, m divided by n, you can rewrite that, 1 log to 2 logs. You can rewrite that as 2 logs of a difference. And then you could go the other way. Over here on the right side, you have a difference of 2 logs. You can merge them to be a quotient. And these properties are really similar. These properties are really similar to exponent properties. Since a logarithm is an exponent, if you were multiplying common bases, multiplying becomes addition. So there's a relationship between multiplying and adding with exponents. Same thing with logarithms. Or if you had a quotient, x to the 5th over x squared, that's the same as a difference, x to the 5 minus 2. So there's a relationship between division and subtraction. So keep those in mind when you're learning your log properties, because the log properties are really similar. Division to subtraction, multiply to add. And the last property is a logarithm of a power. Logarithm of power is the product of the log and the exponent. So this basically means you can change exponents to coefficients. Change exponents to coefficients. So if you have an exponent on your m, you can move that to be a product out in front of the log. So right there. You can also go the other way. If you have a coefficient of p, you can move that to be an exponent on m. So it's right here now. So here are the 3 properties. It looks like 6 properties, but they're really the identical property, just written with the symmetric property of equality, written the opposite way. So here's what it looks like. First, to expand, so we're going to be using the properties on the left side. To expand logarithms, this is log base 4, 2xy. 2x and y are factors, so you could write it as log 4 of 2. And a product is going to become addition. So log base 4 2 plus log base 4x plus log base 4 of y. And that's expanded. And we don't really do anything after that. That's just getting used to using properties. The next one would be log base 4 of x squared minus log base 4 of y. So notice the division is going to become subtraction, which they kind of look the same, which is nice. The division bar looks like a minus sign, so that changes. We can actually use the power property with the exponent right here, exponent right there. So we can move that exponent out in front to be a coefficient, 2 log base 4 of x minus log base 4 of y. And that's your expanded answer. And the last one, just to remind you of power property, you can move the exponent out in front, so you have 3 log x. And that would be the answer for that. It's a lot more common, though, to have to condense logarithms. So that's why I gave you 6 examples rather than 3 examples. So I'll do the first one and see if you can do the next one. The first one, you have a sum. So a sum's going to change into a product. So 2 logs, if we're condensing, 2 logs are going to merge to 1 log. So you're going to have 1 log of base 3 of a product, x times y. And if you'd like to pause this video and see if you could do the middle one. Okay, the middle one we have a sum. So a sum is going to change into a product. You'll have log base 4, 2 times z times w. And that would be your condensed answer. The next one, notice that we have a minus. Minus is going to become division. So we'll have log base 2 of 2b divided by b. And that we can actually simplify. B divided by b is 2. So log base 2 of 2. And log base 2 of 2 we talked about yesterday. If the base and the number next to the base are the same, then that equals 1. That's because we're answering this question. 2 to the x equals 2, so x must be 1. So you can simplify log base 2 of 2 to get 1. On the next one, we can move the exponent, the coefficient be an exponent. We have log base 3 of p cubed. And that's all for that one. The next one's really important with order of operations. If you have a 2 and a 3 for coefficients, you have to move the coefficients first. Before you condense the sum, you have to move the coefficients first. So this would be log base 3 of q squared plus log base 3 of p cubed. And now notice you have a sum of 2 logs. You can condense a sum to be a product. So you'd have log base 3 q squared times p cubed. And pause this video and see if you could write the answer to the next one right now. Okay, on the next one you would have log base 5 x to the 4th minus log base 5 2 to the 5th. And since you have division, division becomes 1 log of a quotient. So log base 5 x to the 4th divided by 2 to the 5th. 2 to the 5th is 32. So that's condensing. The next part of the notes, we're going to use this idea of condensing logs to solve equations. And that's what you'll do a lot more than just the types of problems I've shown you so far. So steps for solving equations with logs. First, you condense. Condense means you're going to have 2 or more logs. And you want to condense it to be 1 log. That's the first thing you have to do is condense any logs. First thing. The next thing, you use the property of equality, which states if you have a log on the same side, on both sides, I mean, log base b and log base b, one on each side, you could cancel, and you would get x equals y. And those are really nice. Those make us happy because you have 1 log on both sides, and it's really fast. The next one I'm going to highlight because students often miss this one, and they just forget what to do. So be careful about this. What do we do when there's only a log on one side, but not the other side? Well, from yesterday, we would write it in exponential form. And pause this video if you remember how to write in exponential form. So exponential form, you would have the base is b raised to the y equals x. So you have to rewrite it in exponential form. Beware of extraneous solutions. If you get log of a negative number, say -5 or something, this is undefined because it has to be greater than 0. It has to be positive. So the next couple examples I'd like to look at, we're going to use these properties of logarithms. So on the first one, notice you have 2 logs, log right there, and it's a sum of 2 logs. So you have to condense these 2 logs. You'd have log base 4, 9 times a equals log base 4 of 27. And this is the kind we like. You have a log on both sides. You can cancel those. You have 9a equals 27. So a equals 3. And 3 is not extraneous because if you plug it into the variable, that is greater than 0. So no problems. Let me show you another one, and then I'll give you a chance to do 24 and 28. Number 30, notice we have 2 logs separated by a minus. So subtraction of 2 logs becomes what? It would become a quotient. You have log base 2, and the quotient is going to look like y plus 2 divided by y minus 2 equals 1. Now this one I'll highlight because oftentimes students will miss questions similar to this. So how do you get rid of log base 2? And you can't just cancel it out. What you do is you leave the y plus 2, y minus 2, and you're going to move to the other side this log base 2. But when you move it to the other side, it becomes a base of 2 with 1 as the exponent. And then you can solve it, and there's no more log. And then, you might be thinking, how in the world do I solve that? Well, you multiply both sides by y minus 2. 2 times y minus 2. And you can distribute and subtract y, add 4, so you get y equals 6. And that would be your answer. 6 is not extraneous because when you plug 6 into here, you would get positive 8. When you plug 6 into here, you would get positive 4. So they're both positive, so it's not extraneous. So you could pause this video and see if you could answer 24 and 28. Okay, we're back. We have log base 7 of a difference, so it's 24 over y plus 5 equals log base 7 of 8. There's a log on both sides, so we can cancel those. 24 over y plus 5 equals 8. Multiply both sides by y plus 5. You'll distribute the 8. You get plus 40. Subtract 40. You get negative 16 equals 8y. So y is negative 2. You might think, uh-oh, I have a negative. Is it extraneous? Well, when you plug in negative 2 right here, it would be a positive 3. So that's not extraneous. It would be a positive, log of a positive number. So that's our answer. On the next one, we have a sum. So you're going to have log base 6 of, and you're going to multiply and get 2a squared plus 4 equals 2. So you have to distribute the 2 and multiply. And this is the kind, which I'll highlight again because students often forget how to do one like this. When you have a log on one side, you have to write it in exponential form, which is b to the y equals x. So you'd have 2a squared plus 4 equals 6 squared. So 2a squared equals 36 minus 4 from both sides. So a squared equals 16, a equals plus and minus 4. And you might think, uh-oh, a negative 4, it's going to be extraneous. But when we plug in negative 4 right here, you square it so that it's positive. So both answers are correct. On number 26, notice that you have coefficients, 2 and 1/3. So you have to move the coefficients first. You have to move coefficients to be exponents. So you would have log base 10 of 6 squared minus log base 10 of 27 to the 1/3 equals log base 10 of x. And now, since you have a difference of 2 logs with no coefficients, you can write log base 10 of a quotient equals log base 10 of x. So what is that quotient? 6 squared is 36. 27 to the 1/3 would be 27 to the 1/3 is the same as the cubed root of 27 based on the definition. So that would be 3. So over 3. Whoops. Over 3. So you'd have 12 equals, cancel both logs, you have 12 equals x is the answer. And see if you could do number 32. On number 32, you have multiple properties that you should use. You have log base 5 of a quotient, 64 divided by 8/3, times the 2 equals log base 5 of 4p. And 64 over 8/3, you could use your calculator or you could go like this. 64 divided by 8/3 is the same as multiplying by the reciprocal. So you would get 24 when you multiply that. So you would have log base 5 of 24 equals log base 5 of 4p. Oh, sorry, 24 times 2. So that would be 48 equals 4p. So p equals 12. And that's not extraneous either. And you can find the second part of this video under part 2.
Wait, you forgot.